Hey guys, welcome to the next part of the tutorial. Today we're going to do a very simple calculation in neural networks, and we will introduce matrix multiplication again, like proper matrix multiplication and how we actually build neural networks. So just to give you a quick primer, a neural network is basically going to be y, that's the output layer, is equal to w star x plus b. Just remember this. So this star is actually an at symbol, which is the matrix multiply. W are the weights of the neural network, X is the input, and B is the bias. So this usually forms a neural network. And after this layer, they usually add something called a nonlinear activation function that is like ReLU, GeLU that we talked about in the previous tutorial. So what we're going to do today is we're going to make an example of matrix multiplication. So you can forget about what I just now said. It's all right. We are going to just make a simple example. So let's say we're going to make a small thing called weights. Okay. Uh, so imagine W is equal to torch.tensor. Okay. Let's put some values 1, 2, 3, 4. So this is a 4-dimensional vector. Now let's say the input. Okay. Input X is equal to torch.tensor. Actually, to be very honest, what I'm going to do is I'm going to write this as 0.1 for the weights, because weights are usually a value between uh, negative between 0 and 1 usually, or even they have negative values also. It depends on what you're doing, how you're doing, but we will keep it from 0 to 1 right now. And for this we will put 1, 2, 3, 4 as usual for our input, right? And what we expect, what is the shape of this? So the shape of this is there are 4 columns, there is only 1 row, so it's 1 comma 4. And for this it is the same, there's only 1 row, so it's 1 comma 4 again. Now what we need to do is what is y, or what is the output. So y is equal to w at x plus b, but this will not work. That is because the shapes are not matching. If you remember the m cross n rule, right? M comma n and n comma p, right? So if this is for matrix 1 and this is for matrix 2, then only it will work. So basically n should be common. Okay, for both of these networks, the shape, if you see, it's 1 comma 4, 1 comma 4. So right now if I write over here print w dot shape, right, and print x dot shape, you will get you will come to know that this is not possible, right? Because it's 1 comma 4, 1 comma 4. We must invert one of them so that it works. All right. So for doing this, we will actually transpose it. So to do a transpose, we will use the view function. And one of the easy ways to use the view function is x is equal to, okay, x dot view. The VIEW view. Okay. Now what do I want to make it? I want to make it inverted, 4 comma 1. So it will convert this into a 4 comma 1 vector. All right. So now when I do 4 comma 1 multiplied by this thing, so let's actually do it. W into x. So W is 1 comma 4, 4 comma 1. That will give a single value. And now let's put the value of dot tensor, the bias of 1. That's it. Okay. So now we can actually print y. So what we will do is we will first actually print w, then we will print x. Okay. Then we will print a separator. Okay. There you go. And finally we should get the value. So if we were to do matrix multiplication of this times this, it's basically 0.1 times 0.2 plus 0.4 plus 0.9 plus 1.6, right? That's the total value. So 1.6 plus 0.9 is basically for 2.5, 2.5 plus 0.1, 2.6, 2.6 plus 0.4 is 30 or 3. So it's 3 plus 1. So we expect, so expected answer is basically 4. Expected answer is 4. So let's actually see if we get that. Oh, we get a runtime error. Expected M1 and M2 to have the same D type but got float not equal to long int. So remember, we again had the same error. So very simple way to do this is x is equal to x dot to D type is equal to float 32. That's about it. And now if we do it, we got the exact answer. We got exactly what we wanted. We got 4. So just to recap, all we are doing is we are doing matrix multiplication, and we're using a weird function called view to transpose it. Ideally, what we would have written is we would have written it directly like torch.tensor of matrix of 1, comma, 2, comma, 3, 4. So this is literally the same value. So actually we can print x right now. This is the same as the value of x. So if I write here x2, right? So this is the same value as x2. Okay. So it's the same thing. Do you see? That's what the view does. It basically just transposes it. That's all we are doing. And that's why we get tensor 4. So this is basically matrix multiplication that we are doing today. And I hope this small snippet of code you remember, because we will be practicing upon this in the coming videos. All right. So this is it for today. We will continue with the next super short video quickly next time. Thank you.